Chapter 6, Learning. Basic questions we're going to be addressing in Lecture 1 here. What is learning? How do we learn via classical conditioning? Can the principles of classical conditioning be applied in everyday life? So what is learning? So if you'd like, pause this and come up with your own definition of learning. My hunch is that most of you have a presupposition about what learning is that you bring to this course, so I'd like you to explore that just for a minute before we actually talk about it. Alright, so what is learning? Textbook definition. Learning refers to a relatively durable change in behavior or knowledge that is due to experience. So we come in the world, and then we have experiences in the world, and then those experiences somehow change us in reliable ways. So we can call that learning. Learning takes place through conditioning, and conditioning in its most basic form involves learning associations between events that occur in an organism's environment. Alright, so in this chapter we're going to be talking about a couple of different brands of conditioning. The first we're going to talk about in this lecture, and we're going to focus on classical conditioning. Names associated with classical conditioning are Ivan Pavlov, who developed this process of learning, and then John Watson, who you're already a little bit familiar with, was an advocate of classical conditioning, early advocate. And then in the next lecture we're going to talk about operant conditioning, which was B.F. Skinner's brand of conditioning. So we'll begin with Ivan Pavlov's classical conditioning. So here's a typical setup in a Pavlovian laboratory. Pavlov was actually a Russian physiologist studying digestion in animals. He actually won the Nobel Prize for his work. But typical setup had a dog yoked. Since Pavlov was interested in how salivation related to digestion, he had a tube inserted into a dog's salivary gland, and the saliva would run down, be captured in a canister, and then a drum would record over here the amount of saliva that was captured over time. And so the idea was to present the dog with some meat powder, some food, and then the salivation would be measured in response to the presence of food in the animal's mouth. So Pavlov began to experience issues with his study. And the issue was that the dogs would begin to salivate in advance of the presentation of the food. That is, when they heard the lab assistant coming with the food, they would begin to salivate. And this was a confound in Pavlov's research because he wanted the dogs to salivate when they were actually eating the food, and so this was a problem. But like any good scientist, Pavlov was thinking, well, maybe there's something basic going on that I need to pay attention to. So instead of persisting to see it as an issue, Pavlov saw it as an opportunity to learn something about the way that learning works. That is, the dogs are associating something with food, and the behavior is in response to that association. So thus was born classical conditioning, and this is kind of how it goes. So we're just going to go over this image. This is a typical study in classical conditioning. Alright, so prior to conditioning, we have what's called a reflexive association between what's called an unconditioned stimulus, the UCS, and a unconditioned response, the UCR. So in this case, we have food eliciting a reflexive response of salivation. This is natural and inborn. It's an unlearned association. Then we have a bell, or in the case of Pavlov studies, we had the footsteps of the research attendant that the creature has really no reflexive response to. So initially, the animal has no response at all. It certainly doesn't salivate at the sound of a bell. And then what do? We pair this bell with the presence of the food. That is, we present the bell slightly in advance of the presentation of the food. And we do that repeatedly until the animal has learned something. That is, it's learned to associate the bell with the food, so now it will salivate at the sound of the bell. So at this point, we could say that the bell has become a conditioned stimulus and the salivation has become a conditioned response. All right, and that's basic classical conditioning. So we're going to go through this again, going over the terminology. So an unconditioned stimulus, again, is a stimulus that elicits an unconditioned response without previous conditioning. So what was the unconditioned stimulus in the early Pavlov studies? It was the meat powder. The meat powder elicits an unconditioned response. So an unconditioned response, a UCR, is an unlearned reaction to an unconditioned stimulus that occurs without previous conditioning. So the unconditioned response was the salivation. And then we have a neutral stimulus. That's a stimulus an organism has no initial response to. In the Pavlov studies, it was the bell. And then that neutral stimulus is repeatedly paired with the unconditioned stimulus. In most studies, the neutral stimulus, that is the bell in this case, is presented about a half second or so before the unconditioned stimulus, until the animal learns to associate the neutral stimulus with the unconditioned stimulus. And at that point, you could say the animal has learned something. So we change the name of that neutral stimulus to a conditioned stimulus. So a conditioned stimulus is a previously neutral stimulus that has acquired the capacity to elicit a conditioned response. So in this case, the conditioned response is the salivation. So let's take a look at this visually. So down here we have the meat powder, which is the unconditioned stimulus, draws forth or evokes the natural response of salivation. That's the unconditioned response. And then we have up here the bell, which is that neutral stimulus. The animal really has no reflexive reaction to whatsoever. And then after repeating pairings of the neutral stimulus with the unconditioned stimulus about a half second prior, then at some point the bell will become a conditioned stimulus because it can now reliably elicit salivation, which now we call the conditioned response. So let's look at a possible real life example of conditioned learning. So are you afraid of lightning? Let's say you know somebody that's afraid of lightning. Little kid has no fear of lightning whatsoever until it's followed by a tremendous kaboom. And humans are prepared to respond with the startle reflex with fear to loud, unexpected noises. All right, so let's see how this would work. Classically conditioned fear response to lightning. All right, so we have thunder, loud, unexpected sound. That's the unconditioned stimulus that can reliably elicit an unconditioned response of fear. So this is the startle reflex. Previously, the creature had no fear of lightning whatsoever. This was a neutral stimulus. However, sometimes learning can occur in a single trial. There's a flash of lightning and giant kaboom. And now with a single trial, that lightning can now be called a conditioned stimulus because all it takes is that flash of lightning to evoke the fear response. So you can say that some fears, such as the fear of lightning, can be classically conditioned. So some of the basic processes surrounding classical conditioning we're going to talk about next: acquisition, extinction, spontaneous recovery, second spontaneous recovery. So imagine we're doing a study in classical conditioning. These are the basic processes that we can observe. So here's a graph that captures all of these basic processes. And I just want to orient us here in this image on the x-axis. Our trials, see these are repeated neutral stimulus and unconditioned stimulus pairings. And then on the y-axis here we have drops of saliva elicited by the conditioned stimulus. So you can imagine this is a tracing on that drum. As saliva accumulates, over time, that is across trials, we see varying amounts of saliva. That's what's captured in these graphs, or these lines. All right, so early on in the study, we see very little salivation occurring at the presentation of the bell, right? And then over repeated pairings of the bell and the meat, what do we see happening? Well, the animal learns to salivate at the sound of the bell because it's pretty darn sure it's going to be followed by meat. And at that point, when we see a fairly steady amount of salivation occurring at the sound of the conditioned stimulus alone, then we can say that the animal has learned to salivate at the sound of the bell. So this is called the acquisition phase, where something is being learned, an association, in this case, between a bell and the presentation of food that draws forth reliably salivation. And then what can be learned can also be unlearned, and that's the extinction phase. So now we're just presenting the bell alone, conditioned stimulus just by itself, not followed by meat powder. What do we see happening with salivation? Right? So pretty rapidly the animal unlearns what it learned initially. That is, over a number of trials of the conditioned stimulus alone, the tone alone, or the bell alone, we see the animal unlearning what it learned initially in the acquisition phase. And this kind of makes sense. It makes sense that animals, including people, will learn to pay attention to signals that reliably indicate the presence of food. It also makes sense, and I think I can qualify this from an evolutionary standpoint. It makes sense from an evolutionary or adaptive standpoint that if a signal no longer reliably indicates food, then we're going to stop responding in a particular way to that signal. Kind of makes sense. Then when we give the animal a 24-hour rest, what do we see? We see what's called a spontaneous recovery. That is, trial 1, we see some salivation. That is, it has recovered seemingly some of the learning it did in the initial acquisition phase. That means it's still responding in the predicted way to the conditioned stimulus, but then it rather rapidly stops responding, stops salivating. And then when we give the animal another 24-hour rest, we see the second spontaneous recovery. It is the presentation of the bell alone. We see a bit of salivation, so it got back just a little bit of what it learned initially in the acquisition phase, and then it falls off really rapidly to baseline. So what this suggests is that animals can learn, they can unlearn, and then they're still open to the possibility that the conditioned stimulus will indicate the presence of food, and then we rapidly unlearn thereafter. So these are typical processes involved in classical conditioning. So some other classical conditioning phenomena that I want to talk about briefly with you: stimulus generalization, discrimination, and higher order conditioning. So we'll talk about each one of these in turn. And I'll give you a little bit of practice with each of these phenomena. So let's start with stimulus generalization. So textbook definition of stimulus generalization is a previously learned or conditioned response occurs in the presence of a new stimulus that is similar to the original conditioned stimulus. All right, so an example of this would be Watson's classic Little Albert demonstration. So here's what John Watson did. This was kind of an awful experiment that Watson did, but it's become a classic because it is a good example of stimulus generalization. So here's what Watson did. He took a little orphan boy, little Albert, little baby, and he banged a gong in the presence of little Albert, and little Albert reacted with fear. So the unconditioned stimulus was a loud gong. The unconditioned response was a fear response. So what Watson did was condition little Albert to fear a white rat. So he presented the white rat slightly in advance of the sound of the gong so that eventually little Albert had learned to fear the white rat. And then what Watson discovered was that little Albert showed fear of objects that looked similar to the white rat. So a furry stole, this was something that women used to put around their necks, a hand warmer, and so forth. So, and other animals that approximated the appearance of a white rat. So what we could say here is this, that little Albert learned to fear white rats, but he also learned to fear other objects that were similar to the white rat. So we can say that at this point there's been stimulus generalization. The fear has generalized to other objects that are similar. And again, this kind of makes sense if you think from an adaptive standpoint that suppose I am hunting on the plains. This is 100,000 years ago, and I become horribly mauled by a lion, and I crawl back into my cave, and fortunately, I'm able to survive. Now, I'm hunting again on the plains. Would it make sense for me to fear only the specific lion that mauled me, or would it make more sense from a survival standpoint to learn to fear large furry things with fangs and claws, generally speaking? And I believe that the answer would be the latter, that it kind of makes sense for us to generalize the fear response to objects or stimuli that are similar to the original stimuli. This helps us live long enough to reproduce. So that's stimulus generalization. So some of our learning generalizes away from the specific conditioned stimulus to other similar stimuli. Stimulus discrimination is just the opposite. Here's your textbook definition. A learned response to a specific conditioned stimulus does not occur in the presence of a new stimulus that is similar to the original stimulus. All right, so here's an example of stimulus generalization. So here's this little guy, right? So there's 2 dogs in the house that he lives. This little guy has learned to fear the mean Chihuahua because the mean Chihuahua is always very vicious and scary. However, this little boy can interact successfully with the old, easygoing Labrador. So in this case, this little guy is able to discriminate between a dog that is possibly a threat and a dog that is not a threat. And again, this is stimulus generalization. So instead of fearing all dogs, he learned to fear this dog and not that dog. And again, this kind of makes sense from an adaptive standpoint. It makes sense for us to be able to discriminate, at least in the case of the fear response. Let's say I am attacked by another human being. It doesn't make sense really for me to learn to fear all human beings, but to be able to discriminate between one human being and the other. One's possibly a threat, the other one is not. Concept check for us here, just to go over some of these concepts that we've learned last few slides. 1, you ate some bad anchovies that made you violently ill. Now the mere smell of them is enough to make you ill. So if you want, you can pause this and consider, in this little instance of learning, what the unconditioned stimulus is, what the unconditioned response is, what the neutral stimulus that became a conditioned stimulus is, and what the conditioned response is. All right, so you can pause because I'm going to talk about the answers. All right, so in this case, the unconditioned stimulus would be the bad anchovies because it has the capacity to elicit an unconditioned response, that is the illness. The neutral stimulus initially was the smell of anchovies, no prior reaction to the smell of anchovies. Now, since the anchovies has been paired with illness, the conditioned response is illness. So now the smell of anchovies is enough to make you sick. So number 2 here, and using this example above, see if you can develop examples of stimulus generalization and stimulus discrimination. So if you want, you could pause this because I'm going to talk about the answers. All right, so an example of stimulus generalization would be you feel sick when you smell any fish. So here, that sickness response is generalized not only generalized away from being simply that of anchovies to including all seafood, and then stimulus discrimination would be you don't feel sick when you smell salmon. So being able to maintain your composure when you smell one kind of fish and lose it when you smell another. All right, so the last phenomenon here we want to talk about is higher order conditioning. This is a little bit tricky, so I'm going to use some illustrations here to capture this. So textbook definition of higher order conditioning. A previously conditioned stimulus, that is the CS, functions as if it were an unconditioned stimulus, the UCS. So think of higher order conditioning as being a two-phased process. In phase one, and this is what we've gone over up till now, we have the classical conditioning of a salivation response to a tone. So we begin with the unconditioned stimulus, the meat powder, that reliably draws forth the unconditioned response of salivation. We pair the tone which is the neutral stimulus initially, with the meat powder about a half a second in advance, and then that tone ceases to be a neutral stimulus. It rather becomes a conditioned stimulus because it can draw forth the conditioned response of salivation. So that's phase one. Phase two, suppose we want to train the animal to salivate in response to a red light. Well, now we can do this. We can take that previously conditioned stimulus, the tone, plug it in here as if it were an unconditioned stimulus, present the red light about a half second in advance of the tone, and sure enough, over repeated trials, the animal will salivate in response to the red light. So that red light is now a conditioned stimulus that can draw forth a conditioned response to salivation. So higher order conditioning is this originally conditioned stimulus, the tone, functions as if it were a true unconditioned stimulus. It functions as if it were meat powder, so to speak. All right, so here's a concept check, just to make sure you get this higher order conditioning. So, child has learned to be afraid of the dark. That's phase one. All right, so how does a child learn to be afraid of the dark? Well, let's say one stormy night, there's a loud boom, thunder, and the little child reacts with fear to that. So the unconditioned stimulus of the loud noise draws forth that unconditioned response of fear. And it is at night, so the darkness has been paired with the loud sound, and so now the child has learned to fear the dark, right? Like a lot of little kids have that fear. So that's phase one. Now, phase two, this is the higher order part. So we're going to complete phase two here, and the concept check here is filling in these blanks here, 1, 2, and 3. Such that the previously conditioned stimulus, that is the dark, right, functions as if it were an unconditioned stimulus. Unconditioned stimulus was the thunder, to elicit a conditioned fear response to the word bedtime. So we're looking at a conditioned fear response to the word bedtime, conditioned through higher order conditioning. So let's start with 1 here. So this is the previously conditioned stimulus in this example was the dark, because it can evoke the response of fear. Bedtime is the neutral stimulus. The little child has no prior response of fear to the word bedtime, but now we pair bedtime in advance of switching off the light, which creates darkness, and now through repeated pairings the little child learns to fear the word bedtime because they know it will mean that darkness will descend. And that is how a child can become conditioned through higher order conditioning to fear the word bedtime. All right, another concept check here. The phenomena of higher order conditioning shows that A, only a genuine, natural, unconditioned stimulus can be used to establish a conditioned response. B, auditory stimuli are easier to condition than visual stimuli. C, visual stimuli are easier to condition than auditory stimuli. D, an already established conditioned stimulus can be used in the place of a natural unconditioned stimulus. A, B, C, or D? The answer is D. An already established conditioned stimulus can be used in the place of a natural unconditioned stimulus. All right, so a couple of applications here in everyday life of classical conditioning. Advertising, I'm pretty sure you're familiar with. So why would an advertiser put a minivan in the middle of a ball field? Well, the idea is that here's the previously neutral stimulus, right? The minivan. So what? It's a minivan. Now the association is with ballparks and fun and mom and dad and grandma and grandpa and picnics and all those good feelings. So what the advertisers try to do is pair these products with certain imagery so that they're conditioning a good feeling response to their product. So products are often paired with images. Here's another one, sex sells, so now we've got Monster, the logo, the brand being paired with a woman. What does an energy drink have to do with her? Nothing whatsoever, but the idea is to pair the brand image with the attractive model so that seemingly the brand will develop a positive response to the brand. So here's how this might work. The woman is the unconditioned stimulus that draws forth sort of automatically and reflexively a good feeling. And then Monster is paired with the woman, so eventually that Monster becomes a conditioned stimulus. That is, when we see the brand, we feel good somehow or another. All branding is classical conditioning, is it not? So when we look at all these images, we might have certain reactions. These images are all neutral stimuli in advance of being associated with various products and experiences with those products, right? So branding is an example of the use of classical conditioning. Therapy. So we've seen a couple examples here how fear reactions and anxiety reactions can be classically conditioned. Phobias are a certain type of anxiety disorder that have been shown to be treatable using principles of classical conditioning, and I'm going to talk about one of these methods known as systematic desensitization. All right, so suppose you have a fear of heights, but yet you want to be able to go on hikes, on trails, and so forth, and climb up and clean your gutters and on your roof and all that, but you can't, so your life is being affected by this phobia of heights. So how might somebody acquire a fear of heights? Well, let's say as a child you climb up a rock and no problem until you try to get down, and then you realize it's much harder to climb down than it is to climb up, and so you become utterly paralyzed with fear. And this is single trial learning. So thereafter, you've acquired this fear of heights. So what systematic desensitization is designed to do is to weaken this learned association between heights and fear and replace a maladaptive fear response with a more adaptive response, such as relaxation. So here's how systematic desensitization works. The first step is to learn a relaxation technique, and there's a number of them, such as progressive muscle relaxation, where you learn to relax all the muscles of your body to induce a deep state of relaxation. So the therapist would train you in a relaxation technique. The next step would be to create an anxiety hierarchy. And what this is imaginary scenarios going from the scenario that produces the least amount of fear to the one that creates the most amount of fear. So here's an example of a anxiety hierarchy pertaining to someone with a fear of heights. So degree of fear is pretty low here, standing on a stool of my kitchen, and then we sort of ratchet up the fear degree here, standing on a step ladder, cleaning my gutters, standing on a balcony on the top floor of my building, riding the chairlift up a steep mountainside. 25. What would be another example? Let's say hiking a very, very narrow trail on the side of a mountain, something like that. So the idea is that the therapist, along with the client, would work through each of these scenarios. So you'd imagine the scenario, then you'd begin to feel anxious, and then you'd work through your relaxation technique, and then you'd take it up the next level. And so the idea is that over time, you would be replacing a fear response with a relaxation response. And then ultimately, you would incorporate this into your actual life. You'd move out of the consulting room and actually be able to expose yourself to these scenarios without having a sense of paralyzing fear. All right, so learning objectives for this section: describe and apply the basic processes and terminology underlying classical conditioning. That is the neutral stimulus, unconditioned response, conditioned stimulus, and conditioned response. Describe the classical conditioning phenomena of acquisition, extinction, spontaneous recovery, stimulus generalization, and stimulus discrimination, and higher order conditioning. Explain how the principles of classical conditioning can be applied in everyday life. And we looked at two examples, therapy and advertising.